Hello, I'm JW. This time we're going to have a look at some older equipment, as in sort of industrial type switchgear. And this is the sort of thing you would have found in older factories and that sort of thing, where sort of switching on larger loads such as motors and industrial equipment. Now, there's quite a lot of this stuff still out there and in use, so it's something you may well come across. But generally it's for new installations. It's not the sort of thing you would be using or expecting to find. Now I've got a selection of these things here, and this is a fairly small piece, and this, as it says, made by MEM or Midland Electrical Manufacturing. And this is basically a switch here, as I say, it's rated on the front 415 volts. This is a three-phase device, and only 10 amps, which does seem rather low for the physical size of it. Now the front of these was secured with a little screw there, and these are designed in such a way that you can only open them when the switch is in the off position, which is what it is at the moment. And if we just open this up, we can see what's inside. Now the screw, of course, normally we go through the lid to secure that in place. So inside here we've got 3 fuses. This is the switching mechanism at the bottom here, and then the handle remains as part of the lid. So basically when you move the handle, it's moving that internal mechanism in there, and that basically interlocks with this here, and that's what actually moves the switch and makes the contact. Now the lid on this one is removable, but essentially when it's in the off position there, you can switch it on like that and off like that. And notice it's got a good snap action because of the springs inside. What you don't want is it sort of making a sort of a slight contact, which can cause a lot of arcing. And if it's in the on position, you can't actually open the lid because it's locked as part of the handle. So here's a view of the insides. This is the switching part here at the bottom. So we've got these 3 metal contacts on this square section bar here. This is made of insulating material, so no actual connection between the 3. And we can see the remains of the wiring here, the red, yellow and blue for each of the 3 phases. And that goes to the right hand terminal on these. And the left hand one is what connects via the fuse there, so that would go in and basically connect those 2 together. That goes via the fuse above here. Then out the top there is where you would connect the load or whatever machine it was you were using. And again, you've got the 3 red, yellow and blue things at the top there. Although interesting in this case, you'll see at the bottom it goes red, yellow, blue, and at the top it goes blue, yellow, red. So someone has swapped those, presumably to get the correct rotation on a machine or whatever. The fuses in the middle here are ceramic. These are rated to 20 amps. And it's just the bit of fuse wire on the back, asbestos pad probably in the bottom there, and very straightforward. So you can see the other contact there, basically comes straight into that via the fuse wire, and then your load is connected at the top. Now the actual switching, say, is done here, and the handle interlocks with this metal piece here. So there's this piece on the back here which basically hooks into that. And when it's in the on position, it's actually locked, so you can't remove the handle from it. And the actual mechanism is spring loaded, so that these go in very quickly and make a good decisive contact, because what you don't want is something to slowly move in and cause arcing and burning and damage here. So if we actually move the mechanism here with this screwdriver, we can see it snap onto the on position. So that's in the on position, and see they're just basically connected each pair together. And of course, likewise, in the off position, it will also be spring loaded, so avoids the problem again of arcing on the contact. So if we move that to the open position, you see there's a good snap action on that via the spring. Now this is a fairly small unit and only rated to actually switch 10 amps, although you can have up to 20 amp rated fuses in there. This was primarily designed to switch something like a motor. And hence inside here we've got the motor horsepower there, 5.5 and 4 kilowatts if it was on a more modern type of measurement there. 415 volts and 10 amps each, and making capacity, which is essentially the maximum load that can be attached there, 46 kA, which is a considerable amount of energy. This is because if you have things like a motor, when you switch them on, the initial current that will flow is many times greater than the rating that it runs at. And of course you will get very large currents flowing here, and that's another reason to have that sprung loaded snap action there. Because if you have a very high load attached, then you will definitely get arcing around here, which can actually burn away and destroy the contacts. Now these are wired so that the incoming power is at the bottom here on the here's where that's these twin wires coming in, and then your load is connected at the top. And this means when it's in the off position like this, the only live parts are actually these three here, and have actually got this bit of shield over the top there. But bearing in mind that they're not fully covered, so that if you poked your finger in there, then yes, you're going to get an electric shock from it. And it's done this way so that the power is only at the bottom here, which means you can then remove the fuse with reasonable safety, so none of these parts are actually live when you may need to replace the fuse. And of course you can then connect your load wires to the top without the power being connected. This has got two at the bottom, probably because it was looped in and then looped out to some other device similar a bit further along. Now these things are made by a whole load of manufacturers. Here's another one. This is made by Bill, a silver link in this case, and it's a very similar arrangement. We've got the handle here. This has some red indicators to show in the on position. This is quite a lot larger, 30 amps this one's rated for, and again it's the same kind of spring-loaded handle there. And as before, you can only open it when the switch is in the off position. And inside, again, it's a very similar arrangement. So we've got the three contacts here with the insulated bar there, high-powered spring mechanism here, so it snaps in and out, and it would have had the three fuses in the top there. So a fuse are actually missing from this one, but also there'd be the three in there. And again, the connections will be the same, so you've got your incoming terminals, three there, and then your outgoing would be at the top after the three fuses. And this one seems to be full of dust and mess as well. At the top here we've got the additional connections there for the neutral, and of course this isn't actually switched, it's purely just a means of attaching them there if the machine in question actually needed one. These are all made of metal, and they're also made in Britain, as in the days when things were made probably grossly over-engineered. And have a look at the lid in this one. It's got the original plate in there. So we have 30 amps, 500 volts, and again it's a three-phase device. And we've got the date here as January 1978, so it's relatively old, but again it's not sort of centuries old or anything, so there's still quite a lot of this stuff out there that's in use. And there's just a bit of a foam seal around the edge there to attempt to keep dust and things out of it. Here's another one. This is made by Dennis, and similar arrangement with the plastic handle this time on the outside, on and off positions, and inside again very similar arrangement there with the spring-loaded actual contact bar here and three ceramic fuses at the top. And we've got the additional contact here with the removable link, which will be for testing purposes. And this will be the neutral, hence on an insulated base here. And the earth connection would be to the metal case on all of these. You can just see the remains of a connection there at the top inside. And cable interest on these would be typically via conduit or something. There's sort of remains of a plastic piece on the top there. And of course similarly in the bottom. This particular one doesn't have a date in, but Dennis Vanguard International Switchgear, and again all made in Britain, and probably grossly over-engineered due to the considerable substantial nature of the metal cases. Now here we have a considerably older one, again made by Mem. This is the Memorex Senior. This is several decades before those other examples there. And you see this one at the top is only rated to 15 amps, 500 volts, so you might imagine it's a fairly small device. But the reality is it's actually quite large, and if we look inside, it's just a switch. No fuses here, it's just the three contacts again. And despite the age of this, the switching mechanism is incredibly similar to the ones we've just seen. So three phases again, all red in the case of the ones here, and then the red, yellow and blue at the top there. Earth connection here just to a stud on the side, and no neutral in this case, as it's fairly common that electric three-phase motors don't require a neutral and therefore were typically not supplied with one. This is just a bit of the rubber seal that's basically disintegrated and turned to a crumbly mess. This one has a handle on the right hand side, and as before it's actually interlocked with the lid, so that you can only open the lid because of this piece here when the handle is in the off position, and once the thing is open you can't actually close it because it sort of interferes with the positioning of the lid and the handle. So it only operates when it's closed, as it will then clear past this casting on the side. Now I've just modified the handle here, just taken it off and opened the lid and put it back on, so we can now actually operate it with the thing open. Of course this is not something you would normally ever do because you don't want to be switching it on and off with the thing open. And even though these are spring loaded, when they actually go in and it's on full load, there's quite likely to be a certain amount of sparking and arcing anyhow, and that's primarily why these cases are so large, so that any arcs or whatever don't actually get outside of it. And these are all made out of basic cast iron. You can see at the top here where something has actually been broken out, probably when it was removed from the installation. That would have had just 3 round conduit entries there, much the same as we've got at the bottom. So again, these are ceramic in the middle here, made out of sort of glazed porcelain or some kind of ceramic material. And that's in the off position, and if we move it up there, even though if we move the handle slowly, because of the spring, it will get to a certain point where those will snap in. And then the handle is basically loose there afterwards, and the same with opening it. Even if you move the handle slowly, it gets to a point and then will snap over like that. Now, although these are spring assisted, if you get old ones of these, it's not impossible for the springs to have gone weak or even broken in some cases. So if you do find any of these that need to be switched off, it's a good idea to actually put a bit of effort into the handle, just to make sure that if the spring has gone a bit weak, the contacts still do open with a good sharp action. Now, so this one's only rated for 15 amps. It's mainly due to the actual load it could switch. So when, say, turn on a motor, it's going to have a very high initial current. Hence, these are, in fact, grossly overrated. But 15 amps is basically what a running current you have for a fairly moderate-sized electric motor. Now, here's another one. It's the same range, Memorex Senior, and same voltage, 500 volts at the top right there. And the current of this one is 60 amps, 60, and that's at the top left. And this is considerably larger physically. As you can see, it's a very substantial piece of equipment. Same kind of arrangement with the handle here, so it goes over the casting there, so you can only open the cover when it's in the off position, as it is here. And if we have a look inside, again, it's a very similar arrangement. It's just considerably bigger, and you see these are the contacts here, great massive chunks of metal. Again, just bolted onto this insulating bar at the bottom, and we've got the same ceramic arrangement here. Same neutral block at the top there with the removable link, and any earth connection again would be just to the metal casing of the equipment. So a very similar thing, only considerably larger, and of course you can imagine if you're going to be switching 60 odd amps there with hugely inductive loads, then the amount of sparking and arcing here is going to be considerable. And it's got the same spring-loaded snap action handle as well. Here's the label in the lid of this one, so 60 amps, 500 volts, and suitable to switch up to a 25 horsepower motor. Again, that's a pretty substantial piece of equipment. Most of the rubber seal is still in the lid, although it's gone very hard and brittle. So this piece at the bottom here just literally breaks off and falls to pieces when you touch it, and that's also what happens to rubber insulated wiring after a while. So it looks fine, but say when you actually get hold of it, it's just brittle and crumbles away. Now, of course, those with the fuses in can be, and obviously were used directly to supply various pieces of equipment, but the ones that didn't have would have to have a fusing and other protection elsewhere. So typically you would have a fuse board, and here's one of those. Now this one again is the same manufacturer, Midland Electrical Manufacturing, and at the bottom here we've got the rating, which in this case is again 500 volts, and the fuse rating either 15 or 20 amps maximum, made in England. And this is all solid sheet metal, a fairly substantial thing. And we see the remains of some wiring here at the bottom there. Now these again, it's just a couple of screws and the lid hinges open. And on these you can actually remove the lid easily just by sliding it to the end, and the whole lid actually comes off. And we have a look inside this one. We've got the original label still inside, so colour coded for the 3 phases, so red, yellow and blue. Someone's actually written a bit in here, heater, each air, presumably hot air, only in those 3. And we've got gill down here, whatever that's supposed to mean. And the top label there just gives you the information. So you can get the semi-enclosed rewireable, which is what we've got here with the actual fuse wire in. You can also get cartridge fuses for these as an alternative. And again, it's just telling you about removing the door. And we've got that sort of 15 amp rating up there. And this particular one, again, it's the made in England, Birmingham. And again, again, these, as is often the case, have not really been filled in. I've just done the one in the middle. But so let's put the description there, the size and the amps, and also the size of cable that was used for the circuit. Now inside, this is a three-phase deal, and it's one phase per each row. This is sideways, normally it'd be vertical, but it fits better on screen if it's this way round. And we've got the ceramic fuses here with the rewirable pieces behind. There's actually three missing for whatever reason. And if we take one of these out, have a look, very similar to what I've seen in the others, so just the fuse wire going across between the two terminals, and the blades that go in. This has a piece missing actually at the top here where it's been broken because somebody probably dropped it on the floor. And if you do get any of these that are still in service, be very careful if you need to remove the fuses, because if you drop this on the floor and it smashes into thousands of pieces, you can't just pop to the shop and buy another one, because of course these haven't been made for a very long time, and you'll then be left with scavenging around on eBay or somewhere, hopefully desperately going to find one, or replacing the entire board, which obviously is going to be very expensive. These may well be asbestos in the bottom. We're not going to be poking that or grinding it up with anything, so not a problem at the moment. Now this does have these shield pieces in the middle here. It's fairly common on particularly old installations to find that these have been taken out and not put back in, so they might just be laying in the bottom of the cabinet, or in many cases missing completely. And if that is the case, then significant caution is required, as we will see. Because once you've taken this away, you've basically got live metal exposed underneath. This piece here, which is where this red wire is connecting, is connected to the actual incoming supply, and of course all of this along the bottom is live. So if the guards are missing, just touching this and basically you're dead. So definite caution is needed there. So that would be the incoming wire, that red one, and this is one of the outgoing circuits here, and this is some horrible crusty old rubber insulated stuff, and with that sort of cotton type covering over the top of it. This one will be the same, and if we look at the bottom here, you see the shield is actually missing. Not only that, the mounting post has been somehow twisted round and severely damaged, so definitely not in the best of condition. Here's a look at the bottom row, and you can see here this is the incoming connection there with the blue phase on this in this case. Now I've also got a blue disc here to identify the correct phase there as well. And so all of the bottom of this is basically live when the thing is turned on, so all of this is completely exposed. Normally you have one of those in there to at least provide some degree of covering, but as I said, they're quite often missing, so significant amount of exposed live metalwork. And your outgoing circuits would connect to the top of the fuses here. So again, you do need to remove the shield above to actually get wiring in. It's essential that working on these that the power is disconnected outside of these by one of those larger switch things which we saw previously. In terms of connecting the incoming wires on these, not something you'll probably be doing these days, but of course it was done originally. This piece here actually is taken off, and then the bottom bit there is actually two screws to secure the incoming wiring into, and that just bolts back onto there. And your outgoing wiring just got your twin screws here, and the wire comes through the hole in the top of the ceramic carrier there. These ones are all intact, but on these the black dots actually cover up the screws which hold the blades in on the back, so if these actually go brittle and fall out, you end up with live screw heads exposed here or here. So again, that's something to be wary of if you've got one of these older things in service. So basically, if you're going to open one of these, turn it off first, because there's a good chance of live parts being exposed in various places. Now the earth connection on this is this stud down here at the bottom, and so it just comes in the bottom there and just goes straight onto the side of the metal case. And this one doesn't have a neutral bar, but you could get them. They basically either bolted in at the bottom here or at the top, depending on which was most convenient. And in this case it doesn't have one, and that was fairly common, because again these generally supplied three-phase equipment, so mainly motors, which of course don't require a neutral, so one was typically not installed. So all we've got here is just the three wires, or what's left of them coming in, the red, yellow and blue, one to each of the three rows of fuses, earth coming into this stud. And for the outgoing circuits, we've got a bit of this sort of remained, this cotton covered thing here. Typically it would be a metal conduit going out via the holes at the top, and you just have the three phases contained within the conduit, and the earth would be the actual metal conduit itself, so there wouldn't be any separate earth wires or anything, just be relying on the single fact that it's connected to the metal case. And of course the conduit is also connected electrically via the threaded connections at the top. So look there, some old industrial type switchgear, and this is just really a small selection. There's many other manufacturers and styles, but they all tend to be a fairly similar design from that sort of era. And although this is fairly old, and this is all old stuff that's come out of various places, there's still plenty of this stuff out there that's in use, mainly because it's usually quite reliable, and if it's working then people don't generally replace it. But some caution is required, say particularly those fuse boards. Live parts are frequently exposed when you open the front cover, because things like those little shields and whatever are frequently not replaced or lost and broken. And the switchgear is usually okay, but you do occasionally get where springs have gone weak, or in some cases just broken. And in that case, using the amount of force on the handle is recommended, because that means it will actually snap open even if the spring has actually broken. And certainly if you've not opened one of these things before, definitely disconnect the power first, because you've no idea what you're going to find if you open the front door of a fuse board. In theory it might be nice and tidy and splendid, but in other cases it could be jam-packed with thousands of wires all jumbled up in a big rat's nest twisting tangle with no space between them to even see where they go, never mind fitting or changing any of the configuration. So that's it with this one, and until next time, thanks for watching.